Thanks for joining today's session. We are going to talk about running a large language model on EKS. So today's session, we are going to leverage NVIDIA NIMs and run on top of EKS, the Meta Llama model. Let me share my screen. Okay, here we go. This is the today's session. This is the agenda. So we are going to touch upon how to run the AI workload in a regulated environment and what are the challenges in a GPU resource management. Then I touch upon what is a NIM and go through the reference architecture of running a NIM workload on EKS. Then we can go for the demo. So any regulated environment, we want the environment, whatever the place where we are deploying our AI model, need to have compliance. So AWS is the best place where you have all the compliance covered. Name it HIPAA or SEC. You can see all the compliance program listed at the slide. Okay, it's all certified. So when come to the running a large language model, the compliance and security is much more important. And AWS is the best place to run Then the second thing we want to talk about is the self-service data and AML capabilities. So when come to the large language model, it's all trained with the public data. But when come to your environment, if you are fine-tuning the model or pre-training the model, pre-training the model, data is your key differentiator. When come to the data, it is not as it right from the ingestion and the processing to the storage and then creating the data for the consumption. Take an example of S3, Glue, and EMR for data processing, and you can use a SageMaker, AI Studio to do the complete data transformation with the no-code, low-code. Okay. And if it is a real-time data, you can use a Kinesis and document store. You can store in Elasticsearch and database like Aurora. RDS, we can store in Aurora. And if it is a data warehouse, you can use the Redshift. And come to the governance, the data zone will help you on govern all the data end to end. Okay. And that is the second thing where the data and the AML has to be self-service. Okay. Using a SageMaker and other tools in AWS, you can do it end to end in a self-service manner. Okay. And robust, secure AML environment. Right from the data we are storing in encryption, you can use a KMS. And if you are consuming any model between the VPC or from the Jumpstart, or if you are connecting with the Bedrock, you can use a KMS. And you can isolate the network using a VPC. And all the EKS and EC2 instance are run in a secure manner. If you're running a model in a serverless, you can use a serverless inference. And if you are saying that I build a model and there is no real requirement of running in a real-time inference, you can always go for the batch inference. You can use a batch job. Then comes a CI/CD. When come to the model, whether you are building a classic machine learning or an AI model or even a large language model, you need to have pipeline right from the data creation, validation, testing, then deploying. You can use a SageMaker pipeline to do it. And for the governance, you can use a SageMaker Clarify, and where you have complete information about responsible AI, what is the data set, why this prediction had happened. And you can also use the model card, make sure the complete life cycle and the intent of the model was built, including a SageMaker registry, where it is stored, when it is trained, what are the hyperparameters we use, everything you can leverage it. And monitoring, of course, you can use the managed CloudWatch, Prometheus, and Grafana to do the model monitoring. So running in an AI workload in a regulated environment, it need to be compliance and secure, self-service data AML capabilities like a data-driven decision, and build and deploy scale using a SageMaker and other tools, and operate at a confidence. When come to today, we are going to touch upon on the inference only. In a future session, we are going to touch upon the fine-tuning. Then we will touch upon how to do the pre-training. When come to this today's session, the inference, you can see this report. If you are running any ChatGPT to run every day, it is taking $100K to run it daily, and it is higher cost, and the GPU is very scarce. There is a scarcity for GPU resource, so it is higher cost. Then come to the scalability, elasticity, and multi-tenant. Okay, so if you are deploying the simple model in a single GPU, and if it is not used, then it is the waste of resources. And if it is so many people are using the same model and it need to be scaled automatically, this is another challenge. Of course, performance, compliance, monitoring, and security by default you need it for your model. Okay, this is the next level of challenge. That is where we are trying to address using the two services which we are going to touch upon. One is the NVIDIA inference microservices. What does it do? What they have done it, any large language model or VLM, okay, video VLM model or text to speech model, any model you are using, they have bundled as an image. All you have to do is just download the image and run on the Kubernetes platform. Okay, I will walk through how you can create the API key and run through it. Okay. And it is using a TensorRT. If anybody uses a TensorRT, it is built for running inference in an optimal manner. And it also send out all the metrics, health check, and everything. Okay. So that we can easily build on top of it rather than reinventing the wheel, taking the model, composing it, packaging it, and then deploying it. You can use the NVIDIA inference microservices to do the model. Okay, let's first talk about the NVIDIA microservices. So let me go to the NVIDIA page. NVIDIA catalog. So you can go here. You can see the collections. You can see any model. Even you can see LLAMA, Mistral, all kind of models you can see. This is a model you can see. And 1 minute. So this, anybody who want to follow this, you can data on EKS is a portal. You can check it. All the instruction we have done with a slight modification, leveraging this. So if you go here, it has a set. Okay. So I touched upon NVIDIA one. I will touch upon the next other components after creating this one. So go here, log in, and you can create your personal key. Since I already had it, I already created my personal key. So I did log in. Okay, so I created a key and given the access to the, you can create a key like this, info service included ngT kettle and create a key. And after that, you can come here and check on the catalog of the models they have, which we have seen before, right? We have multiple models. Okay, we have created a key and you can download the Llama model locally. I also tried it. So if we go here, okay, NVIDIA catalog model. You have a lot of model. Even if you want to try Mistral, you can do it. We have taken only one model because I want to run it on a single GPU. So we have taken this model, but you can always take this model, pre-trained model, or any model, whatever the model available. Okay. That is the first step. I taken the model. The next one I want to talk about is this is the architecture I'm using. Here, first step is we are running the model on the GPU node. Currently, I'm using a G6.2x large, and this is a blueprint given by the AWS. You can check on the Terraform code. Okay, here it is. Okay, I will show you the GitHub link after this. Even in a video description, I'll mention it. So what happened, right? Where we create a EKS cluster. Inside the EKS cluster, it will leverage the Karpenter to create a GPU instance. And if there is more request comes in, it automatically scale. We have put a threshold of 5, but you can scale according to your need. Okay. And all the metrics will go to the Prometheus, and we are using Prometheus adapter to get the Prometheus information. And we are seeing in a Grafana when come to the large language model, it is it need to be stored on your file system. So we are using a EFS and storing this particular model. And also this is a model we are using. Okay. And we have a NIM K8S service, which is nothing but a NVIDIA microservices. Okay. And all this was done by Terraform and it is running under the VPC. Let us go over the code. First, I want to check. We download the API key. Then I want to go to this GitHub. So I downloaded the code. This is the path of the 1 minute. Okay, stop share. Stop share. Share. Your new share. I'm sharing the screen. Okay. Share. Okay. So here I downloaded it, the data on EKS. And after that, these are the two important files you need to go. So inside the variable.file, file, you can see the version of the EKS cluster we are using. And you can replace your NVIDIA token here, but you no need to, it's not mandatory. And here, this is the model we are choosing. I'm using a 8B instruct model, and I'm number of GPU is one. I'm doing it. If you want to have four instances where the same model need to be run, you can just give the count as a GPU. So automatically provision four instances. Okay. Then inside the add-on, you will tell what instances. Okay. The small learning I had is it here. If we go here, 1 minute. So first it will creating the storage class for the GPU. Then it will install the NVIDIA plugin and everything. Then enabling the Karpenter. Okay. Then we are enabling. Okay, this is a plugin, NVIDIA plugin. We are installing it. Then enabling the Karpenter. Here we are giving a node pool name. So we are giving, this is a node pool name and we are tainting the node pool. Only it will be, this node will be placed only if the GPU exists. Okay. Here I'm giving the multiple values will be there, but I just to make sure that only one value was given, G6 instance. And here also we can see multiple, in a GitHub link, you will see multiple values, 2x large, 4x large, and multiple. I mentioned as 2x large alone. This is where you can you try to make a changes and keep it only on demand. If you are making as a spot, you don't find the spot and it is keep on waiting. So this changes you have to make it. And what we are telling is once we made these changes, all you need to do is come here and do the install.sh. Okay, from here install.sh. What does it do is it automatically provision the whole infrastructure. Okay. Here NVIDIA NIM, you can see it is automatically download that particular, run it inside the run inside the VPC. Let me stop and share my screen, other screen. Okay, so so you can see now I put up everything here, so you can see the NIM dashboard. Okay, Let me see this. So it first created it created a VPC. You can see VPC. Okay, this one I will take it later. It automatically provisioned the VPC. Under the VPC, you can see all the subnets, including the private subnet and public subnet. Okay. Okay, let me put this one. It created a 3 private subnet and 3 public subnet. And after that, you can go and see the EC2 instance. Oh, we can check the EKS first. EKS, EC2, EFS. Okay, it created a EKS cluster. And under the compute, you can see only one managed node group. Okay, this is for the CPU instance to run all your management components and Grafana, Kibs, and other things. And if you look at the add-on, you can see all the add-ons are installed, okay, including the ABS driver, then to monitor the CloudWatch, then kubeproxy and CodeDNS installed. Okay. If you look at the observability, I not enable the observability for now, but you can enable it. Here inside that EKS, where is it? Okay, inside the EC2, you can see 3 instances running, 2 GPU instance and one GPU, sorry, 2 CPU instance and 1 GPU instance. This GPU instance was launched by the Karpenter. If you look at it, you will see this node pool. This is a node pool which is used for creating this, and it is tied to the cluster called NVIDIA Titan Server, the EKS cluster. Okay, let's go and check all the pods. Okay, so this is first it's installed everything, then go to the pods. You can see here, clear kubectl get pods -n nim. So okay, so you can get like this. Sorry, sorry, small case. Get all in nim. So you can see this is deployed. You can see the service got created where this nim will be deployed, and this is a pod is deployed, and you can see only one minimal pod is running. Okay, you can once it's done, I did a port forwarding. I think the port forwarding is still maybe running in the console. So I did a port forwarding. After port forwarding, what I have to do is I just need to check on the local host. This instruction, it has all the instruction, but I mentioned like a few changes I did it because it's not working without those changes. New tab. So I did a port forwarding of the 1000, and I'm just giving the prompt once upon a time. Then it is running, it started giving the response. See, this is a response it is getting. Then what am I trying to do is I'm deploy the open UI. So open UI is the kind of console you can connect your large language model and run it. So it's completed, and you can go to the lens. You can go to the lens. This is where I did this. If you go open, this is running there. I tested already, but let it run. Okay, gmail.com. So once you run it, okay, you just need to log in and you can see the model, whatever the model we deployed. This is a model. We can say that what is AWS reinvent. If you type it, it will talk about, you will get a response from there. Okay. So now it is connected to the large language model running inside your data center, sorry, inside your VPC, and you can see it is connected to your large language model deployed within your VPC on EKS. Okay. So this is the response you will get, and you can do the performance testing also, but I just want to test up to here. And there is a way to do the performance testing. I even did the performance testing. Okay. So you need to we need to install the Triton's jar. I see module. Sorry, I will show you this. You need to run the Triton server. I even tried it locally, but then I finally went with the. Okay, if you go here, Docker image. So this is a Triton server. Inside the Triton server, you need to go and run the performance module. So I taken here, where is this? Okay, here is. I just deployed it. I went to the inside that particular container for Triton server deployment, and I ran a performance testing against the model. Okay, and you see the metrics: latency, what is the average nanoseconds for the latency, number of tokens input done, number of input token done, output token done, all those things. Okay, if you want, you can try this again. So here I given an output token is 100. I don't want to give it more, but but just doing the testing. So it's not only the Llama 3B model. If you have any requirement of any small models which can fit into the single GPU, try this one. I'm gonna find out. I'm gonna going planning for a session where we can train the model from the scratch or the big model how we can deploy in EKS. I'm working on it. Future session we can cover all those things. Okay. So one small thing, you need to change the measurement interval in higher. They give 4,000, but you need to change it to higher one. So this is the average, min, and all those information. You can get it when you are running this metrics. And there is a metrics you can run. They call it as all the metrics also you can monitor by using this URL, which is again, it is provided by the NVIDIA. I told you, right? The NVIDIA NIM will provide all the metrics. So you can see all the metrics. You can collect it from here. So then what I want to show is the Grafana. So to monitor that, we have deployed the Grafana also. Under the dashboard, you can see Kubernetes. It's same places we deployed. Can see the cluster. Okay, click on the cluster. You can see all the nodes running. Okay, and how much space, all the metrics you can see from here. Okay, input and output. And if you want to go for the particular part, I think it's going at the namespace level. If you go to the NVIDIA, this is the name. If you go under that particular one, you can see this is a pod which is running, and you can see the metrics. You again go down to the particular pod, you can see like all the metrics from here. But when come to the large language model, right, we have important metrics. This is a metrics which is very important. Like what is the first check, how much time it taken for the first check token to be generated, and other inter token means what is the following up token, and also give completion of the token, how much time it has taken. So we have seen this in a command line, but you can say the same thing in a Grafana also. That's all. So I just to do some small recap of what we have covered today. Okay, so here it is. So we have tested this. We have seen it is deployed under the VPC. We have seen the AKS cluster. We have seen the Karpenter. Yeah, if you want to see the Karpenter, right, you can see this custom. That is custom under the config, custom resources. Oh, I know it's under the custom resources definition. You can see the Karpenter. So it is created a node client. Under the node client, you can see it will launch on the GPU instance. We have seen that configuration in Terraform, but you can see it clearly here. So this is the details, you can get it. And yeah, node type. See, this is the values. You can see it is giving, and the node pool, it automatically, based on the node client, it automatically create the required information here. Node pool. So from the node pool, you will allocate the pod will be allocated to this one. Make sure we have a taint and taint allocation. If it is no GPU, it won't schedule that. So that's all about the configuration. So we have touched upon the Karpenter, and we can scale it if there is more request come. The horizontal part auto scaler will be help. Sorry, the Karpenter will make sure that it is auto scale it happening. EFS is where the data is stored. Let me see whether I can get into the node and check it out. We can go to the instance, click on the instance, and you can connect session manager, connect. Inside the node, you can always go NVIDIA SMA. So this is the node. It's I talk about what kind of node type we are using. Okay, and if I finish, see, so it is mounted here. So that's all I want to you guys to have a look at it. Okay. There is a logs I want to see. Yes. Yes. Rep nim. Okay, here it is. This is what it will run. It start the ID. Okay, so is it to hyphen user? Okay. Docker PS hyphen. So sorry, the Docker won't be installed. This is this is a GPU instance where you can the large language model is running. Okay. So that's all for this session. Then I want to show you, is there anything I missed it? Yeah, I think I covered all the things. So with this end of the session, you would have had a good understanding of how to deploy the model, large language model on top of the EKS. Okay. Feel free to have the go through the session, and if you have more inputs, feel free to pass on my comment and share the feedback. Thank you.